name is Eugenio Guevara.
My name is Emilio Martinez.
My name is lamas.
The first problem reads as follows. A company is redesigning the cans used for packaging their product. Height restrictions on the store shelves mean that the cans must remain 10 inches in height. The plan is also to increase the radius from 4 inches to 4.2 inches.
So the first problem is to approximate how much will the volume be affected. So we need to differentiate the formula for volume of a cylinder. So we have volume is equal to pi r squared times height, radius squared times height. So we differentiate this. Before that we have to replace the height because it's a fixed value. So we'll just remove that and plug in the 10. Okay? So we differentiated the V over dr is equal to 20 pi radius. Okay, now we have this and we're looking for the differential of the volume, so the dV. So we'll have to isolate it by passing the dr to the other side. So our final formula is dV is equal to 20 pi r times dr. Now we have to plug in each value to get the approximate of the volume change. So for the dr, dx, which is in this case the dr is the same thing, is equal to the change in x or r. So we have to find the change in r first so we can plug it in. And our first radius, as it says in the problem, is 4, and they want to change it to 4.2. So we just subtract 4.2 minus 4, and we get the dr, which is 0.2 or 0.2. And we just plug in the other values. We have the dV, the differential of volume, is equal to 20 pi 4, it doesn't matter which of the two radiuses you use, times 0.2. Okay? And after multiplying all this, our dV is 16 pi inches cubed. So the second part of the problem asks us to find the actual change in the volume. So as you know, the dy, it's almost equal to the change in y. And in this case, our y is our volume. So the dV, which was 16 inches cubed, 16 pi inches cubed, okay, is almost equal to the change in v. And to get the change in v, we have to subtract the second volume and the first volume. That's equal to our change in v. So we have to plug in the values of the radius and height in the volume formula for both of them. So our change in v is going to be equal to one of the volumes, the second one. So pi 4.2 squared times 10 minus pi 4 squared times 10, and close the bracket, and this is going to be our formula for the change in volume. So after doing some quick math, it's going to be 176.4 pi minus 160 pi. Okay? So the final change in the volume is going to be 16.4 pi inches cubed. And as you can see, this is almost equal to the 16 pi.
So the problem asks us now to get the approximate and the exact change in weight. The formula for that would be weight equals 0.6 pi radius squared times height. The height remains a constant, so the value of the height is 10 inches. We can write this as 0.6 pi radius squared times 10, which would be equal to 6 pi radius squared. When we differentiate this, we get dW equals 12 pi radius dr. Now we're applying the values for this part, so it's dw equals 12 pi times 4 times the change in radius, which is 0.2, and this would be equal to 9.6 pi ounces. Now, this is the approximate change. So the problem also asks us to get the exact change. The exact change in weight is with the formula of change in weight equals the change in volume times 0.6. As we got from the previous part of the problem, the change in volume is equal to 16.4 pi inches cubed. When we rewrite this, we get 16.4 pi times 0.6, which is equal to 9.84 pi ounces. There is a restriction on weight increases of no more than 2 pounds for each can. Will the new cans meet the restriction? So the problem says that we have a restriction on weight increase, and the weight increase is of 9.84 pi ounces. We have the information that 1 pound equals 16 ounces, and we know as a fact that 9.84 pi is about 30.8976. So knowing that this is like 16 times 2 is 32, and this is under 32, the 32 value, the cans will be acceptable according to the restriction stated in the problem.
So this is our section 2 problem. We have the following function, and we're gonna find the integrand with the substitution process we're seeing in class. So first we find the u, which is this one. So we write it over here. U equals 5 minus 6x with an exponent of 1/2. U prime is this, you find the derivative of this one, which is -3 over square root of x. And dx is equal to du over -3 over square root of x. So we're gonna start to find the integrand by substituting. So it's 8 over square root of x. We replace this with a u, and we replace this with what we have over here. So as you can clearly see, we can cancel these x's, and I'm gonna rewrite it, which is 8 -3 u9 du. So now we're gonna find the integrand, which we add a +1 to the exponent and divide it by the same thing. So this is equal to our answer is 8 over -30, and we replace the u with what we have over here. And we can simplify this part, which is 4 -15.